All right, so the next thing that we're going to talk about is symmetry. The general idea for symmetry should be familiar to you. Okay, you probably talked about symmetry in biology with how the left side of people and animals and lots of plants looks like the right side. It's either identical or very, very similar. So symmetry happens a lot in nature. We also have symmetry in math. So let's talk about symmetry to the x-axis first. Okay, so symmetry to the x-axis. So if I can draw this steady. So symmetry to the x-axis could look like this, or it could look like this. Okay, forgiving my drawing skills just a little bit on this. All right, we know that this is the x-axis right here. And in order to be symmetric to the x-axis, we have to know that it reflects along the x-axis, which I'm drawing in here as green. So you can either think of this as putting a mirror here. Okay, if we put a mirror along the x-axis, would it look the same? Or if you fold the paper. So let's say that red drawing, let's say that red drawing is wet paint. If we folded the paper and then we opened it up again, would it look the same? For those two, yes, they would look the same. These two are symmetric to the x-axis. All right, now in math, we need something a little bit more quantifiable than folding a piece of paper. So we need to give this some sort of quantification so we can do this. So let's look at this one on the right. Let's say that we have the point right here. Let's say that this is the point 3, 1. Okay, so we go over 3 and we go up 1. Let me write that just a little bit better. Okay, so this is the point 3, 1. All right, now if I ask you, where is that point's mirror image? Okay, where is the reflection of that point? It would have to be across the dotted line. It would have to be over here. And if we went over 3 up 1 to get to this point, we'd have to go over 3 down 1 to get to this point. So the reflection would have to be at 3, negative 1. Okay, so 3, 1 is our original point. 3, negative 1 would have to be our reflection. And so if you look, any point that you pick on here, okay, if we pick a point there, its reflection is going to be across the x-axis. If we pick a point here, the reflection is going to be across the x-axis. And the same thing over here. Any point we pick, the reflection is going to be on the other side. So in general, if we pick any point xy, we have to know that its reflection, x negative y, is also on the graph. Okay, so look at the pictures. For every point, any point that we pick xy, we have to know that x negative y is on the graph. So that gives us our way to quantify this. For every xy, we have x negative y on the graph. Okay, and if that's true, then we know that this is symmetric to the x-axis. Okay, so what would we do if we don't have a picture? If we have a picture, we can think of it as a mirror folding the paper. Well, what if we don't have a picture? What if we have an equation? Well, if we have an equation, this concept tells us how to figure out if it's symmetric. So we need to know that x negative y is on the graph. Well, we talked about this at the very beginning of 2.2. If a point is on the graph, that means it's a solution. And if it's a solution, that means that we can plug it into the equation and get a true statement. So what this means is that we should be able to replace y with negative y and get a true statement. And in this context, a true statement is the original equation. Okay, so this is what we want. We want to be able to replace y with negative y and get the original equation back again. So let's try one. Let's say we've got x is equal to y squared, and we want to know, is this symmetric to the x-axis? Okay, so we're going to replace y with negative y. And let's see what happens. Well, if we have negative y squared, that means negative y times negative y. Negative times negative comes out positive. And y times y is y squared. So this is going to simplify to be x equals y squared. Is that the same as the original equation? Yes, it is. So yes, it is symmetric to the x-axis. Okay, let's try another one. Let's say we have x plus y equals 5, and we want to know, is this symmetric to the x-axis? So we replace y with negative y. Okay, so x plus a negative y or x minus y, same thing. Is that the same as the original equation? No, it's not. There's nothing that we can do to simplify this. The only trick that we can try to get this to match the original is to multiply through by a negative and see if that fixes the signs. Remember, when you multiply through by a negative, it's going to change all of the signs. So we're going to get negative x plus y equals negative 5. Is that the same as what we started with? No. So this is not symmetric to the x-axis. And that should make sense because it's a line. It's a diagonal line. It's not going to be symmetric. Okay, so that's symmetry to the x-axis. We replace y with negative y and see if we get the original equation. Okay, so now let's try symmetry to the y-axis. If the x-axis made sense, then the y-axis is very similar. So let's say we have something that looks like this, or maybe, oops. All right, so let's say that we have that, or maybe we have, just for something a little bit different, we'll do another triangle. Okay, so this time we're looking at the y-axis, which is this one. Okay, if we were to put a mirror over the y-axis, or if we were to fold the paper with wet paint, would these two images line up? Yes, they would. Okay, so let's give this some sort of quantification now. If, let's say this is my point over here, let's say this is the point 3,2. Okay, let's say this is the point 3,2. Now, where is this point's mirror image? This point's mirror image is on the other side, across the y-axis here, at negative 3,2. Okay, so this time we're going across the y-axis. Same thing here. For any point here, its image is going to be across the y-axis. So this time, for every xy, what happens? We get negative x, y. We get the mirror image across the y-axis. So this time, the x's are changing value. So for every xy, we have negative x, y.